From ContainerDays Hamburg, this video is proudly presented by NetBox IT.
So today we'll talk about these things. I assume everybody has one. Can you show me your phone? Let's do the stadium thing, so I feel like a rock star, at least once. Like, cool. So you probably think these are quite easy things, not the devices themselves, but like network connectivity behind it. Well, we have them up here. Let's mute them and store them safely in our pockets or wherever you want to store them. Today we'll talk a bit about how the network side of these things are working. I can't tell you much about the devices itself, to be honest. They're very complicated by themselves. But in fact, also the network side is not as trivial as you would expect. It's not as easy as just connecting you to the internet. There is a couple of things we need to do in between. But let's take a step back and talk about us, or who we are. I'm Adrian, this is Alessio. Today we are here to talk to you about our journey at Swisscom. Swisscom is the largest service provider, or connectivity provider in Switzerland. We're quite known also among the world to be one of the most modern network operators. And we actually host the world's best mobile network. Just a slight hint. If you're not customer, no, just kidding. This talk is part of a series. So we've been here last year, 2 years ago. We've been at other conferences, KubeCon and many others. So it's been a journey, and we've been quite public about what we did over the last years. So you can see, a couple years back, I didn't even bring all of the talks. There is way more. I'll show you a QR code at the end where you can see the full list of talks. Today, we'll kind of combine what we've done in the past. So we talk about how we use what we've talked about in the past and kind of bring that all together. But let's start with a network. And I've brought you here this amazing slide. It's a very simplified view on a network. You see on the most left side, there is your user equipment, your phone. Could be anything. It could actually be an IoT device as well. Then we have the magic antenna. It's so-called radio access network. That's the things you see all around. Nobody wants it, but everybody uses it, right? Then we have that magic block, which we'll talk about a bit today. I'll not scare you. I'm not going to go into too much detail, but like we talk about the core. That's the thing, the backend that actually works with your data and does magic things. It allows us to send you a bill at the end of your month. So that's, for us, very an important thing. And then to the right-hand side, you see there's a data network. It could be the internet. It's mostly the case for probably most of you. It could be something else. It could be a private network. It could be a company network. It's basically anything. So let's have a look at that mobile data core. It's a bit more complicated if you look at it like that. Everything you see in the gray box is what we consider the core, and each of the blue bubbles is a network function. So each of these things has a very specific use case it does. And there's a lot of them. So this is just a selection. I'll not explain all of them in details. I wouldn't even be, I couldn't even, to be honest. They're very specialized functions that do one single purpose. But you see there is a small design, or a smart design, actually. There is just one of the blue boxes in the data path. And everything else is basically just administrative. So these blue bubbles nowadays are containerized, which is fancy for us because it's no longer like physical boxes, but it's not as simple. So they're in a container format. They're not yet that cloud native, to be honest. We typically deploy them using standard tooling, like Helm. Configuration, however, is a bit a difficult thing. So telco is a bit backwards thinking, or let's say old-fashioned. It's deployed using Helm. It's configured using other interfaces, so not very cloud native. Typically, what you do today is you have netconf call. That's a separate protocol. You throw a huge XML at the container, and then the container somehow knows what to do with it. Then there is the thing about scaling. You need a lot of these bubbles or containers to run a mobile core. You need more than one mobile core to be a network operator because you need redundancy in the kind of cores. And you want to have them as close as possible to your end users because the closer it is physically, the faster your network, or at least the better the user experience. So one core can easily have like 2,000 pods and about 5,000 independent configuration line. So it's quite a lot of things you need to have and kind of keep aligned across all your cores. So I brought you here an example XML, just a small part of it, to give you a bit of an impression what that could be. It contains things like IP addresses, subnets, VLANs, DNS records, variables, some infrastructure-related things. It's a lot of redundant information in there. Actually, some of it we could not configure in there at all because it could be discovered. And this is what we want to talk about today. So let me summarize. We have a couple of problems with today's core as we have it. And one of them is configuration. It's like thousands of parameters we need to have in sync across multiple cores and instances. For scaling, we're a Swiss company. Switzerland is small. This is Switzerland. It's quite easy for us. We actually just need one core. Topology-wise, it's also the country is small enough. But we have for roughly in these locations. Actually, I didn't put the effort in to precisely make the locations. So we have like 4 of these things. So it's somewhat a scale. If you're looking at Germany here, they probably have like about 20 of these or more. So you need to scale kind of n times the same thing. And then you have n times 5,000 configuration parameters you need to keep in sync. And lastly, it's a closed ecosystem. There is a couple of big vendors that sell you these telco applications. They like to sell you additional software and obviously also a lot of professional services with it. There's nothing open about. You do not get a lot of documentation. You do not get open interfaces. You don't get source code access. This is a problem. We like open source. We want to have open standards. We want to work and kind of look into these things. So proprietary software, quite a big problem. So let's look at the approach we took. And I will revert the order. For the closed ecosystem, we are starting to building open source and leveraging also the open source. So we use the CNCF tooling and ecosystem for what we do, but we've also contributed back to it. So we started to create new code, add, and open source that. Scaling is done using GitOps and Kubernetes operators. So the more you have standardized, copy-pastable, or even kind of one file that's the source for everything, the better. And configuration, we do intent-driven. This is a big shift in the industry. You saw there's like an XML. You have to create each of these XML files for each of the containers separately because they have different configuration. We start to do that intent-driven, and I'll explain a bit what that means. So we start with a high-level description of what we want to achieve. We want to have a 5G core with whatever parameters. Super high level. We throw that intent, and this is super simplified, at first level of operators. And that operator then reads the intent, knows what to do with it, and starts to use some other operators. Let's say there's like 2 more. And they, again, have some aggregated view. They will, again, have yet another layer of operators. And with that, we kind of build a tree. But the cool thing is, we only need to take care about the top-level intent. Everything else is automated. So who cares about the exact IP address that is configured on one container? We don't. It should be automated. And one of these layers will handle that, and it will configure it for us. So, could be more, huh? Let's look at a simple example. We'll have the demo for this one here as well today. When we want connectivity from the mobile data core that lives in some cloud, there is some routing in between, some transport, and then some antennas. We need IP addresses for the core. We need some transport configuration, so it's actually connected. And we need some configuration of the workload, so there's like a peering between the routing tier. That's very roughly what we need to do, and we'll show you how we do that in the demo right in a few minutes. IP management is done through Netbox. You can have a look at it. It's an open source tooling. We've created an open source operator. There is a talk later today as well about that one. Routing is done through our own routing configuration tier, and on the cluster level, we do it with MetalLB. And configuration is managed in a cloud-native way with a tool called SDCIO. There is also talk about this one specifically later today. We'll not go into the configuration management side because there is a dedicated talk for that one. So that's it in terms of introduction. Alessio will now explain to you our demo and then show you the real thing.
Yep, thanks a lot, Adrian, for the great introduction, or which problems we have at Swisscom, and at a high level how we try to solve them. So what I want to show today first is a slide and then a practical demo about it, and we will be describing how basically we provide connectivity to network functions. Network functions for our core, I remember you, are Kubernetes applications, which are depicted here in this picture in the top right corner with the cluster. Basically, those could be whatever kind of Kubernetes app running there. We need to provide connectivity. How do we do that? We do it through the infrastructure, which is depicted here with the red box as routers. So it's a bunch of network appliances that needs to be configured basically to provide connectivity. How do we do that? You might have understand it. We do it with Kubernetes operators. Kubernetes operators that are deployed in this big blue box, which is a Kubernetes cluster that we call management cluster. So the whole idea here is that we define at high level an intent, so a KRM, Kubernetes Resource, a CR of a kind network, where we specify at very high level the characteristics that this network, this connectivity needs to have. In this case, you see here there is a parent prefix, and a prefix length. So we say that we want a block of /26 IP addresses from this parent prefix, and bunch of other parameters which we didn't detail in this slide. So the idea is that as a user of the operators, I define this high-level intent, and then I give it to the first operator in the hierarchy. The first operator here is called config assembly operator, and it's basically responsible of parsing this part that is in red here on the CR, and roughly output what is on the number 2 here in the slide. So 2 output resources, a prefix claim, and IP addresses claims. It's going to be clear later on for what those are used. What you need to keep in mind now that the output of the first operator becomes the input of the second operator in the chain, Netbox Operator. So basically, the Netbox Operator is the one that is going to talk through the API to the Netbox, which I remember you is the source of truth for IPs. So it's the IPAM is basically the component that is assigning IP addresses to everything in Swisscom. So through API requests, the Netbox Operator is going to get IP addresses and prefixes. Those resources basically that are obtained by the Netbox Operator are needed to configure the routers, which is actually the next step. So once those resources are ready and available, the config assembly operator knows them and uses them to produce the input router configuration. This router configuration is now taken up by the next operator in the chain. That's the network as a service operator, which is basically talking to the infrastructure, again, through API, and configuring whatever is needed to provide the needed connectivity. Once this is done, so we are here at step 7, the next part is configuring the counterpart, so the application to consume this connectivity. So what is done here, the config assembly operator produces BGP peering and IP address pool, which are used by our load balancer. As Adrian said, it's MetalLB. So basically now we have the upper part configured, the down part configured, the infrastructure, which brings basically to connectivity. So there is BGP peering for the ones that are more technical in the network side, BGP peering between the load balancer and the routers, so the applications has now connectivity. Yeah, what I want to show now is exactly a demo about what I described here in this slide. So let me, I think you see correctly my screen. Yeah, what I prepared here, it's a kind cluster. So it's a Kubernetes cluster running on my machine. And in this cluster, we have all the boxes that we saw before in the slide. So you see here in the first line, there is the config assembly operator, which is exactly this box that I showed before. We have as well the Netbox operator here, so it's one pod in one namespace, and it's this guy down there. And then we have here slightly different names, so the network as a service operator in this slide is called Tor operator. Why Tor? Tor is basically the name that in Swisscom we gave to the platform as a service for providing connectivity in the infrastructure. We have as well here in the default namespace, you could see that there are a bunch of pods starting with Netbox, and that's basically a deployment of the Netbox, of the Netbox IPAM. So now that you know a bit what we have deployed here, let's have a look at the, if I find the command, yep, at what we want to achieve. As I told you before, we want to have connectivity. So this is the CR we are gonna basically give to the operators. It's nothing different from what you have seen before. It's just the name of the kind is slightly different. Again, that's something that has to do with some Swisscom internal naming, but basically exactly the same thing. So we are claiming here a network of /26, so we want to have a block of the /26 IP addresses, bunch of other parameters, and maybe mainly let's focus on the last one, which is telling us where and how we want the output of this operator, and it's gonna be in Kubernetes resources. So basically what I showed you before here, so those components here, this one and this one, we are gonna get them as Kubernetes operator in the same cluster where the operator turns. Another option that our operators support is, for example, output them in Git. So you might imagine you could chain them together with your GitOps approach. So let's go then in the actual doing of the demo. I'm gonna split the screen in 3. Here we launch this watch. Here I should have another one in my history. If I don't, yeah, here we go. So basically I'm gonna now do a kubectl apply of this CR that I showed you before, and we are gonna see what the operators do. It's gonna be quite fast, but I'll try to walk through what's happening. So you see here, as soon as I hit enter, the reconciliation loop started. You see that's the resource that I created is not yet ready. There are different steps going on now, and basically the IP remedy is already done. And basically what happened, the Netbox operator talked with the Netbox, and it got back the IP addresses, which you can see here. We have 3 IP addresses and 1 prefix. The 3 IP addresses, as you might imagine from the name, if you're a little bit familiar are the IP addresses for the provider edge routers, so the one that will establish BGP peering with MetalLB. And then there is a virtual IP, so it's the VRRP for those two provider edges. Other things that are created, ones that actually is being created now is the connection point. Connection point is just a Swisscom name to refer to the VRF. So it's basically the configuration of the VRF in the router. You see here that it's already completed. Everything is done. We have as well our BGP peers. So if I take back this picture, we already have those two things here. It's really fast. You see that in less than 1 minute, we have all of that configured. But it's not only about being fast, but it's as well about being able to manage those resources in case of problems. So I'm going to simulate now a problem, and I'm going to delete a connection point, which is basically simulating a deletion of a VRF into the routers. So as soon as I do that, you see here that the main resource is not ready anymore. Why? Of course, something went wrong. I deleted it. And you see here that in the related resource, the connection point something is going on. We have got now a new resource that was created. So basically what happened is the operators did their job at the reconciliation, then the next reconciliation step, they basically just recreated the missing resource, and now it's in pending update. So there are some API exchanges going on in order to make the resource ready, which is going to happen in few seconds, I hope. And we will see that basically, as I was speaking, the main resource, so the high-level intent, became ready again. This is very important to have as well this readiness loop status, because the consumers might know if everything is ready to be used or not. Let's now try to delete the high-level intent. I can do it with that command. There you are going to see now that there is a complete garbage collection happening. So all the resources have been cleaned, and trust me, they are cleaned also in the backend. For example, in Netbox, the IPs are not allocated anymore, and everything is basically cleanly tear down from all the components, which is something that most of the time we as developers, we don't take into account, let's say. Yeah, so that's it. That was it about the practical part. I have now a bunch of other slides to show you where I would like to recap a bit what we have seen. I would like to start from the technical benefits of using Kubernetes Operator. First one is that we have everything KRM based. So everything is based on the Kubernetes Resource Model, which is great when you want to have all your all the parts of your system communicating all together. You imagine they speak all the same language, so you can integrate seamlessly everything. But it's as well flexible. So as I told you before, the operator can output the results in Kubernetes resources or as well in Git. So this could be branched together with the GitOps CI/CD. So you're not only confined, let's say, to the Kubernetes world if you need to go somewhere else, which brings as well the chance to gradually adopt the operators. We have seen 3 operators now, but it's not given that you need to use all of them. You could just start with one, which is basically exactly as well what we did at Swisscom, and then you can add all the others later on. We've seen as well that it's quite powerful in terms of reconciliation, so you don't need to take care about all the resources. You just define the level intent, and all the lifecycle is handled by the business logic of the operators. And you have as well garbage collection, so you delete basically all the resources when they are not anymore needed. Let's have now a look a bit at the organizational benefit that Swisscom had out of all of that. As Adrian said before, telecommunication industry is a little bit of legacy. And there used to be very heavy processes. For example, in what I just showed you to when it's about providing connectivity to network functions, it used to be very, very slow process and very manual. So there used to be many people involved for creating this so-called IP low-level design, LLD, and it was done in spreadsheets. Today, we achieved much more, let's say, a pragmatical approach with operators, and we were able to greatly reduce the time from days to hours. That's as well reducing all the exchanges, mail, all the different tools that you need to copy-paste around. You can imagine all the errors. Now it's done in a matter of seconds by the operator that parsing the high-level intent, produce the low-level intent. Then the implementation as well is much faster. No need to coordinate between people. The operator, they cooperate between them in a programmatic way, so it's much, much faster. And last but not least, as well, testing can be automated. Before used to be completely manual. Now you can, for example, leverage this Kubernetes event and have frameworks like TestCube to wrap all together. That's what basically allowed Swisscom to evolve into a techco from a telco. And yeah, just a few words about our learnings. What you need to avoid basically is try not to build all the operators at one. So one operator that does everything. You should not try to configure everything, but just focus on the particulars that you need. And you should as well not think that you are alone with your problems. Everybody in the industry and other in the industries probably had the same problem with KRNs. What you should do, you should aim at decouple and chain, so have a different, a chain of different operators in the hierarchy, one specialized to do exactly one specific thing. You should leverage abstractions, which means focus on essential configurations that you need, use frameworks. Of course, for example, when you need to build the operators, what really helped us was using the Kube Builder, which speeds up a lot the development phase. And then, of course, share the code with everybody else here. I guess everybody's gonna be happy. If you share the code, that's what we are presenting in the other talk from our colleague Leah at Stage K1 at Ford. She is gonna give more details about the operator that we built for Netbox, and same for the talk from Alex and Marcus at Stage K6, where you're gonna see some more details on the configuration of network functions through operators. With that, that was it. I hope you enjoyed. And yeah, we have now time for questions.
All right, so I understood you were writing your parent operator using Kube Builder. Have you considered using something like Crow or Crossplane as an alternative? Since, as I understood it, you were basically just maintaining other Kubernetes resources.
Yes, we did. I can give you a very lengthy answer why Crossplane is definitely not the answer. I will not do that today. We can do that in the coffee because it takes a lot of time. We really emphasize the fact that you should solve one problem with one operator. This is super important because otherwise it's not maintainable over the long run. The goal is also to spread the operator maintenance into the various teams. So the team that does the data center interconnectivity automation, they should provide an operator as an interface on the long run. We're not there yet, but kind of having that modularity will solve that for us, or kind of we'll be able to hand over things. Yeah, this was just simpler for us. It's also very purpose-built, to be honest.
Thanks.
Thank you.
Yeah, we do.
Hello. Hello. I have a rather general question. Is OpenStack still in use at Swisscom, and how does it relate to Kubernetes?
Oh my God.
Yes. So OpenStack is the foundation. So we're heavily depending on Ericsson. OpenStack is the foundation Ericsson builds on for virtualization. For containerization, not. So we're moving away from OpenStack, actually.
Because you have also network function virtualization in OpenStack,
Yes.
I heard. Okay.
Yeah. So that's actually also a question of generation of mobile core. So the 4G core is built on virtual machines. The 5G core is built on containers. And with that, there is a technology shift not only on the virtualization layer, but also on what's the underlying virtualization.
Okay, thank you.
So we have questions on Slido. Thank you, by the way. So let's start with the first one. Why do you use IPv4 and not IPv6?
Because people know it. No, it's easier on the slide.
Yeah.
You can use IPv6 instead. It's interchangeable. Code-wise, we don't care. It's just people know it easier, and it's a bit shorter to write.
So you're saying that IPv6 is harder to use?
No, it's just not as easy to read.
Definitely. Okay, so the next one, do you use specific shell prom theme or so, and what is the name? I think it's related to your
I have
terminal.
a theme, but I have no idea what's the name. I could search later on and tell you.
Damn it, I switched the question. Too bad. There was a question regarding using what you built on Azure, specifically using the AGIC model and their own load balancer. The question might be like, is it possible to use what you built on a cloud provider like Azure or Google or AWS, whatever?
Yeah, at the moment, the output that is produced is specifically for MetalLB. So the CR, they adhere, of course, to the CRD definition of MetalLB. So it would need some extension to be done to produce the needed configuration for other load balancer, but the building logic would stay exactly the same, basically.
Okay, next question. After writing your own operators, would you do it again, and how will you maintain them?
Yeah, I would say that we would do it again. We are doing it for many, many other things. Here we presented 3 of them, but the same logic we are using it, for example, in the releasing strategy. We need some components, and we are building them based on the reconciliation logic. So definitely that's what Swisscom is aimed at in different parts. How do we maintain them? I guess we are going to see it. We are not yet in production with it. We are going to be soon. Yeah, so I guess that would be a learning that maybe we will present one day in the next conferences.
Maybe next year. But we're also trying to push together with other industry partners that vendors build things in a cloud-native way and expose operators or similar technology so that we don't have to do it all by ourselves.
So we are waiting for you next year to present the advancement of your projects. Okay. Another question: do you create multiple operators completely independent and deploy them independently, or do you also have one operator with multiple controllers?
Both. So the answer is yes. We have independent ones. We have operators with multiple controllers. So you saw the CCD primary network operator or the config assembly operator that actually has multiple controllers because we just showed you one of the many paths it has. With the other controllers, it has other output options and other configuration options.
All right, let's go for the 3 last questions. What cloud provider does this run on? I think it was OpenStack, I heard.
It runs on OpenStack or on-premise on bare metal Kubernetes.
Okay.
So it's not a cloud, public cloud. Telco typically runs on premises. So.
Yeah. How many of the high-level resources do you have to manage in production, and how do you deploy them? Seems like you're not really yet in production.
Yeah. We use Flux among the tools that are maintained there. So basically, it's a full GitOps cycle. We do need as well a bit of Argo workflows for some workflows that cannot fit inside the other, let's say, tools. And yeah, how many what was it? How many of high-level resources? High-level resources, I would say we have 4 or 5 categories in the end, yeah.
All right, let's make it fast. What cloud provider does this run on? We haven't said that. Last questions. Are you using self-hosted Kubernetes when you are creating multiple CRDs? It will cause, at some point, bottlenecks for etcd clusters. Yes.
I think that at the moment we are not at the scale that we could cause bottlenecks with all the, the numbers of CR, the high-level one that we have is not that huge, and even when you go down to the level. So far we didn't experience any bottlenecks on etcd. And yeah, first part of the question, yes, it's self-hosted.
Yeah. But we're well aware of the problem, and we're monitoring for that. So we should be ready once it pops up.
Yeah, but especially as tricky etcd is. Yes. Okay, thanks a lot for all the very interesting questions. Thank you too for the very cool session. A big round of applause for our speakers, please.
Thank you very much.
From ContainerDays Hamburg, this video is proudly presented by Netbox IP.